Collaboration of Scientists by Ishan, Anish, and Shravant.
An atom is the smallest unit of ordinary matter that constitutes a chemical element. Every solid, liquid, gas, and plasma is made of either ionized or neutral
As you
atoms.
can see in the image below, this has been the evolution of atomic models throughout the years. Further in the presentation, we will be explaining you how each one has developed and how each one relates to one another.
John Dalton, 1844. The first person to introduce and pioneer the idea of atoms was a UK based scientist called John Dalton. He proposed that all atoms are tiny balls of material and that atoms of a particular element are identical. Dalton used small wooden balls to model atoms and showed how they could combine to produce compounds, as shown in the image to the right. John Dalton also pioneered the atomic theory. His atomic theory stated, everything is composed of atoms which are indivisible building blocks of matter and cannot be destroyed. All atoms of an element are identical. The atoms of different elements vary in size and mass. Compounds are produced through different whole number combinations of atoms. A chemical reaction results in the rearrangement of atoms in the reactant and the product compounds. While Dalton's theory has been revised over the years due to scientific advancements, his development of the original atomic theory has been credited with the atomic mass unit being named after him, Dalton. J.J. Thomson, 1897. J.J. Thomson was a UK based physicist whose most important work was the discovery of the electron, the first subatomic particle. He discovered this through running a cathode ray through an atom. From this, he realized that the current atom model did not account for positively and negatively charged particles. Therefore, he proposed a new model called the plum pudding model, which is shown to the right. Thomson stated that a plum pudding is very similar to an atom. The raisins represent the electrons, and the pudding dough represents a positively charged ball. This meant that the atom was a positively charged ball with negatively charged electrons embedded within it. In the year 1906, Thomson was awarded with a Nobel Prize for his discovery and work on the electron.
Ernest Rutherford was a New Zealand-born scientist who is credited for the discovery of the nucleus. He proved this theory through an experiment called the Rutherford's gold foil experiment. Through this experiment, he proved that there is a small, massive center to atoms. By this, he meant there is a small center and it has mass inside. This center later came to be known as the nucleus. Rutherford also stated that atoms are mostly hollow or empty except they have a positively charged center. He then created a new atomic model which came to be known as the Rutherford's atomic model. This model had a positively charged center with electrons scattered around. He also won a Nobel Prize in chemistry for his theory of the atomic structure.
Niels Bohr, 1930. Niels Bohr is credited with discovering that the electrons in an atom are fixed onto shells or orbits. He did this through measuring the energy transmitted and absorbed by an atom. Through this, he came up with the model we use today, except for the fact that he did not include neutrons in the model since they were discovered later by another scientist called James Chadwick. This model was called the Bohr's model and consisted of a positively charged nucleus and electrons in fixed shells surrounding it. In the year 1922, Niels Bohr won a Nobel Prize in the field of physics for his ideas.
James Chadwick is a UK-based scientist who proved Rutherford's theory, which stated that the atoms must contain a third particle. He thought this because the masses of atoms that were being measured were heavier than you would get from just the masses of protons and electrons added together. Chadwick discovered the neutron through realizing that the unusual radiation that had been observed in experiments was actually a neutral subatomic particle. This discovery completed Bohr's model. The new atomic structure consisted of positive and neutral charged particles surrounded by shells or orbits which had fixed electrons. For the discovery of neutrons, James Chadwick received a Nobel Prize in 1932 in the field of physics.
Scientists collaborating with each other can usually have a lot of positive and negative impacts. These impacts could be political, social, and
Almost
economic.
everything you use in your daily life has either been invented or discovered by scientists. Science literally puts meaning to life and the life around us. Most of the world's most important inventions happen due to the collaboration of scientists. Scientific collaboration can be defined as an interaction between scientists. Now, this interaction can take place in various different forms, including the borrowing and lending of supplies or resources, seeking input from an expert, or partnering with colleagues who have a similar field of knowledge in order to ensure a rotation of fresh and new ideas. Overall, scientific collaboration has many different impacts on the world, some being positive, some being negative, and some even being life-changing.
Political impact, international collaboration. Most countries usually have no restrictions for scientists collaborating with someone who's not from their nation. In fact, the United Nations Educational, Scientific and Cultural Organization, or UNESCO, advises scientists to work with scientists of other nations and says that it has become a must in today's world. A study conducted by UNESCO shows that a lot of scientists are already collaborating with other scientists from different nations, and that 86% of scientific articles have some form of international collaboration in them. The only reason a country might not allow an international collaboration might be because the two countries are at war or one of the countries is under sanctions from the United Nations. Political impact. Why international collaboration is important. International collaboration between scientists is considered very important. This is because scientists in different countries have grown up and learnt in different environments, different education systems, and around different people. This means they can have very different approaches towards the same idea, and this could be both helpful and cause conflicts. Having different approaches to the same idea could be really helpful, as it can allow scientists to understand the idea from another's perspective and could lead to breakthroughs and even potentially the idea being developed faster. However, the different perspective could also lead to conflicts and possibly increase diplomatic pressure between the countries and potentially even lead to war. An example of international collaboration being helpful is the development of the atomic structure. While this example might not have scientists physically collaborating with other international scientists at one time, it does show how one idea was developed from a lot of different nations during different times, and it ended with all the countries getting some credit. It also increased the whole world's knowledge on atoms. Here you could see different scientists working from different countries on the same project. First there was Dalton and Thomson, both from the UK, and then there was Rutherford from New Zealand, and finally there was Bohr from Denmark. All of these scientists contributed to the atom and helped increase our knowledge from it, and each of their countries got some credit, which is how it is like in the scientific world. Even if countries are collaborating together and scientists of countries are collaborating, each country will get partial credit for the discovery.
The importance of scientific collaboration on society. According to Walter Ricciardi, who is the president of the Italian National Institute of Health, we are all going to face life-ending problems in the near future, and our lives as a community or a society solely rely on the hands of scientists. We currently have no idea what kind of problems the future may bestow upon us, but our only solution is scientists collaborating with other scientists, solving the problem of our communities. The famous slogan, "Science in Society," is no more just a slogan, but a key perspective for citizens, scientists, healthcare workers, and politicians. Scientific collaboration will allow different perspectives on the same problem, resulting in a more efficient problem solving process, eventually saving the world. According to the growing need of collaboration among young scientists is now more essential than ever before, with careers and research becoming more uncertain and unpredictable. We need collaboration between scientists to happen much more frequently now in order for the large population of the world and society to take a step impact. Why do scientists not collaborate more? One of the world's greatest developments in the past 100 years has been technology. Earlier on, technology was non-existent or very expensive. In order to solve problems and get solutions, scientists had to collaborate with other scientists to get new perspectives and ideas on how to solve the problem. However, in the 21st century, technology is easily accessible by anyone, and with the use of search engines such as Google, which answers most questions you have, the need of collaboration goes down, and hence nowadays scientists don't collaborate as often. Another reason scientific collaboration doesn't happen as often is because of the recent rule where the research of scientists is funded by the government. The government gives the scientists their desired amount required for the research, and in return, the scientist has to show some progress towards a solution. However, previously, you had to pay for your own research, and hence, scientists used to collaborate to divide the funds and share the credit. The need of collaboration to divide funds is no longer existent, and hence, scientific collaboration is low.
Economic impact of the collaboration of scientists. Brief. Scientists cooperating together has different economic advantages and disadvantages, like privatization, availability issues, and scholarly burglary being the principal drawback. With financial development, shared assets, and price and acknowledgement being essential advantages. Privatization. A negative economic impact of scientists working together is that of licensing each innovation and selling it to make a shared profit, like a company of scientists. While it means scientists are recognized, the rights of a specific innovation or machine can be sold to the highest bidder, constraining availability for others. When a firm or individual has purchased the rights to a logical development, it cannot be utilized by others, particularly the ones who may require it. The selling of innovations or administrations planned for open use being offered to the private part is called privatization. Privatization of railroads, metros, aircraft, squander removal framework, water filtration framework, and corner stores, just as government organizations has happened previously. For example, in England and Wales, the provision of water and wastewater services was moved from the public to the private sector in 1989. In some countries, partial or complete privatization leads to the unaffordability of clean purified water or food that has been tested and cleansed of bacteria. Patents. There are various arguments for and against patenting scientific inventions, which is the immediate action taken most often by scientists when they work together. The main positive being the idea that a patent is a form of protecting intellectual property, that people are rewarded for their work and cannot simply be copied. Another factor that supports patents is the supposed growth of competition and incentive for innovation. If people get rewarded for their scientific inventions, such as Thomas Alva Edison for the light bulb, they will feel more inclined to develop and create, resulting in more scientific breakthroughs for mankind. A disadvantage for patents is then the limitations for people who cannot afford them, or the great cost of using patented technology and inventions, and how they therefore become inaccessible to those who cannot afford them, especially in terms of pharma- pharmaceutical, and medical advancement. Economic growth. A greater number of scientists working together would lead to them sharing ideas, discovering, and creating more for the world. Such inventions within a nation of scientists working together could boost a country's economic growth when sold to others and would rest of the world, as a lot could be made and done on the basis of a discovery or invention which scientists were involved in together. Scientists being able to further develop each other's work would also lead to constant human evolution and greater revenue for many industries. As said by Isaac Newton in 1657, if I have seen further, it is by standing on the shoulders of giants. An example of such an occurrence would be the discovery of radioactivity by Henry Marie Curie and Pierre Curie, who collaborated with each other. Sharing resources. Scientists, when working together, can share resources, research, ideas, and facilities. They can share research without having to pay royalty, can further develop one another's research, can share ideas, and can work within the same laboratory. Using the same using the same materials and facilities is cost effective and provides required facilities to even to scientists who otherwise would not have access to them. Intellectual theft. Scientists working together could have infringement issues. They could steal each other's ideas and inventions, patent them, and sell them to companies for personal gain. This would be classified as intellectual theft and would result in a scientist losing credit for their work, losing recognition, losing money, and possibly being accused of plagiarism. Such actions would be illegal, yet undertaken for personal economic gain. Evaluation. Overall, despite there being as many economic disadvantages of scientists working together as advantages, intellectual theft can be reported and recognized, privatization can be limited and restricted, and patent fee can be reduced. As negatives can be avoided and successfully combated, the positives outweigh them. Shared resources would greatly benefit individual scientists, and economic growth would greatly benefit countries.
Conclusion. Scientific collaborations have many impacts in the world. International collaboration between scientists have a lot of political impacts. They can be positive and negative. While scientists collaborating across nations could potentially pose a risk to the relationship of the respective nations, the positive impacts that international collaboration brings are far greater and outweigh the negative impacts. Collaborating across nations could not only improve the relationships of the particular country or scientist, it also helps increase the world's knowledge in science and makes life easier and efficient for mankind. This is because international collaborations can help scientists get different approaches on one idea, and this will allow for more breakthroughs to be made and more problems to be solved.
Scientific collaboration also has some social impacts. In the near future, we as a community will face many problems, and the solution to these problems can only be found by scientists collaborating. It is essential for scientists to collaborate now than ever before. However, there are still some factors that are stopping scientists from collaborating. Technology has taken over society and now is the perfect solution to any problem. With its easy accessibility, anyone can answer any question they may have. This is reducing the demand of meeting up and discussing solutions to problems. Government institutions now also fund the research of scientists as compared to the past, where you had to pay for your own research. This meant if scientists collaborated, they could divide their funds and share credit. To conclude, scientific collaboration could change our society and save our future if done correctly. However, could also lead to serious problems, even causing conflict between countries.
To conclude, Positive scientific collaborations are very crucial to the 21st century because every time scientists collaborate, it has a massive positive impact on the world, whether it's politically, economically, or socially. Thank you.